Yeah, good evening, everyone. Switch on your cams. Let's start off. So this was the last thing that we did. We are doing rotational equilibrium. Perfect. Let's start off with a problem. There we have an L-shaped rod here. In equilibrium. There. So this is mass m, length L, mass m, length L. Shaped rod is hinged at one end. In equilibrium. Find theta. So you took an L-shaped rod and you hinged at one end. And it is suspended from the ceiling. How do we proceed with this? Right, Anisha. Right, Lakshika. We have two answers. Think about it. If you draw the FBD, right, the forces will be Ny, Nx. Now, since you're saying it is in rotational equilibrium, the torque should be zero. Suppose if mg is here, then won't the system rotate this way? Or if mg is on the left-hand side, rotate this way. So there's only one point where you can be, if there is an equilibrium, that mg also should pass through the hinge, isn't it? Think about it. If I take torque about the hinge, there's no other position where, torque can become zero. So torque about hinge should be torque due to Ny, torque due to Nx, and torque due to Mg is zero. This guy is gone. Therefore, torque due to Mg is zero. Therefore, Mg should pass through the hinge. So center of mass should be somewhere on this line. Isn't this the property of the center of mass? Remember, when you suspend a body, the vertical line passes through the center of mass and the point of suspension. So once you got this, this is 0, comma 0. This is L by 2, comma 0. This is 0, comma L by 2. The center of mass will be on the center of these 2 points, which is L by 4, comma L by 4. So this was the point of suspension. And if I draw a line till here, you're asking me this theta. So this length will be L by 4, and this vertical length will be L by 4, 3 L by 4. If you just draw the line, this is how it would look. This is L by 4, comma L by 4. So this is 3 L by 4, and this is L by 4, and this is theta. Tan theta is 1 by 3. Check. Make sense? So once you figured out that mg will pass through the vertical, this thing hinge, physics got over. After that, is just max. Get the center of mass and finish off the coordinates. You can also try this as a homework. Suppose if you have a hinge, if you have a half ring, that you can try. I don't remember the answer. I think it is 2 by pi or something. Check it out. That you can prove it as a homework. Clear? So this is one type of question. So when you suspend a body, right, the center of mass has to pass through the hinge. So using that concept, you can find the center of mass and finish it off. Clear? Next one. Everyone got this? Neil, I can't see you. Vartika, Maulika, clear, na? Got this. Rehan, clear, right? Vidyut, clear. Utsa, Aryan, got this. Perfect. Next one. We have an incline here. We have a solid hemisphere. This angle is phi. Find phi in equilibrium. Let's call it alpha, maybe. This setup is in equilibrium. Means it is not falling down. It is just there. It's a solid hemisphere. Find alpha. How do we do this? Try, take 2 minutes. It's more of a geometry. Again, the logic is the same. If you draw the FBD, you will realize how the forces are. Did you draw the FBD? How many forces are there? How many are there? 2, 3, 4, 5, 79, 83. How many other? There are this was a center, right? So this is the point of contact. There is normal reaction. There is friction, right? Because it is rough, there is a friction also. And what is the third one? Mg. What else is there? That's it. 3 forces only. How did you get 4? There's normal, friction, and Mg. If you resolve Mg into components, then okay, fine. But forces are only 3. Okay? Now listen to the catch again. Same story. Huh? If you take torque about this point, F ka torque is 0, N ka torque is 0, Mg ka torque also should be 0. That means the only way this is possible is if the Mg vector from the center of mass passes through this. Do you agree? So the center of mass should pass through, that vertical point there. Now, if I just draw something little big here, I'll do one thing. I'll just draw it like a line. So this was the center. Let's call it O. This was your center of mass. Let's call it C. This is the point where it is touching the incline. So this is theta. Let's call it A. This angle is alpha. This angle is alpha. This would be 90 minus alpha, and this is alpha. And this mg vector, right? It should pass through this point here. That's a vertical line. So if that is theta, this is theta. So this is theta. Perfect. So I got a triangle here. Which is O, C. And remember, this CA is a vertical line. This is alpha. This is theta. And O to C ka length is 3r/8. And O2 O2A will be how much? O2A will be R. Mm, why will this be alpha? This won't be alpha, no? Hmm. This would be alpha. Then this would be 180 minus alpha. I don't know this angle actually, but I know this angle. Pi minus alpha. You're done. Then use sine rule here. Sine theta by 3r by 8 is sine pi minus alpha by r. Sine alpha is 8 by 3 sine theta. Check. Like I told you, the main thing is once you got this FBD there, and it is all geometry after that. Check it out. Have a look at this. Any doubts on this? Clear? Next one. So equilibrium problems, right? That is the main idea. So whenever they say some problem is in equilibrium, draw an FBD, write the force equations, horizontal, vertical, and torque equation. That will give you 3 equations. And choose a point where the maximum number of forces pass through. So the life becomes easy in terms of calculations. The next thing, toppling. Now, if you take a body, right, there is no force, nothing. So this is how we draw normally. We say the weight is acting from the center of mass. Now, in reality, at every point on the surface, there is a normal reaction. At every point, there's a repulsion. But for convenience, what we do, we just draw one normal reaction and we take it the center, right? And there's no external force. The normal force is uniformly distributed on the surface. And so what we take, right, that n what we are taking is always the average. We take the average n to be at the center. But if you apply the force, suddenly the game changes. If F external is applied, suddenly you'll observe the right side of the block is experiencing more normal reaction. Right now you're sitting, right? If you try to lean to the right side, you'll observe, your weight is shifting more to the right side, isn't it? If you shift to the left, you can see your weight is shifting to the left. You can clearly feel it. So n, which we keep talking about, right? N is not exactly in the center every time. It depends on the situation. Till now, we never bothered because dimensions were never given, right? We never talked about toppling and all. So if we have to draw an FPD for this, So remember this thing. Next time, whenever you draw an FBD, this is how the FBD would look. External force, your weight mg, N won't be in the center, N will be to the side. So the normal reaction will be more towards right. There is more pressure or more force on the right part. Now, if you keep on applying more and more force, at critical value, the body is balanced on the edge. Meaning this is how it looks. The entire weight is acting on the corner. So N will be like this. If there is a friction, friction will be like this. Mg like this and F like this. And if F further increases, body topples. So this is the FBD when it is about to topple. So that is the main thing here. So when you say FBD, right? So the change in FBD is the normal reaction won't be on the center anymore. So whenever someone says the body is about to topple, this is the FBD you draw. The entire weight should be on the edge. Let's see, I'll show you how the frame questions on this. So the main thing is FBDs will be drawn this way now. You can't draw the N in the center. Have a look at this page. Any doubts on this? People went to IIT Bombay, Tech Fest, seen the campus, then go. You guys should have gone to see the campus at least. I told even the medical students also, like generally I told them. So some of them actually went. And this guy went there and there was some, aeroplane ka some competition is there, flying ka thing. So there was a runner-up thing or something, and one of the aeroplane crashed. They said you can take it, and this guy brought it. And that guy was so happy. देखो मुझे aeroplane मिला करके. Medical people are more interested. I said that only. So anyway, you're not going to go to IIT, right? So you can take it. The other students will go, so they will directly take it from there. We don't need to steal stuff. Let's see a question on this. Your senior's exam is in 3 weeks. Why does normal force shift? This is what I was saying. Because there's more pressure on the right side, so N should be more to the right. If it doesn't shift, the body will rotate, right? Someone has to balance the torque of that external force. That way. So let's say we have a body here. This is 3A. This is A. Mass is M. Someone is applying F is equal to mg by 4. The ground is rough and there's no slipping. Means it's not sliding. So, first question, find position of the normal reaction. Where will N act? Second, find F max, so maximum force, if body does not topple. Tell me one thing. Listen, tell me one thing. How do you know whether this problem is regular loss of motion or toppling? When you see a question, how do you figure out, अरे boss मुझे toppling करना है? No, I should not do toppling. I should do like a regular problem. Can someone tell me? Right, Anika. Anyone else? What do you guys think? Think about it. Till now, in every problem that we did we ever give dimensions of the block? We have never given dimension of the block. We never cared what is the size, what is the width, isn't it? So if the block dimensions are given, that is the biggest hint like boss toppling is involved in the question. Clear? So that is how you figure out it's a toppling question and not a regular one. No slipping is still fine, right? That is okay. Dimensions, that is the biggest clue there. Try this. Give it a try, 2-3 minutes, then I'll show you. Yeah, just start with the FBD. The story is still the same. Mg, normal reaction, friction. Let this be x. So indirectly, I'm asking you to find x. Try. You got a minute. That's the FBD. So whenever toppling is involved, just make sure not to draw n in the center. Draw it to the side at a distance x and start the question. Things will fall in place. Same story. Horizontal forces, vertical forces, torque about any point is 0. Preferably choose center of mass. A by 4. Okay, that might be right. Yeah, one answer, Arjun. Then there's a still second question, right? Do that. What if find the maximum force if body does not topple? Same story. See, step 1, horizontal forces, vertical forces. Be careful, don't write F is equal to mu n. You don't know that. Nothing is given. So horizontally, F is equal to friction. Vertically, N is equal to mg. I will take torque about center of mass. I always prefer center of mass in this case because, if the body starts slipping, every point becomes a non-inertial frame. So then you have to apply pseudo force. In that way, center of mass is better. We will discuss more about that later, why center of mass is a very preferred point when things accelerate. But for now, let's take, we can take any point in this case, actually, everything is at rest. Torque due to N, torque due to friction, torque due to mg, and torque due to capital F is 0. Mg is gone. This guy would be N into X, direction would be plus K cap. Friction will be F into perpendicular distance A by 2 minus K cap. This is F into perpendicular distance A by 2 minus K cap. N into X is equal to F into A because F is equal to friction. We end up with X is equal to Fa by N is mg. Now, the first question, X is FA by mg. F is mg by 4. A by mg. So the answer is A by 4. Second question. You said the maximum F, right? So X is equal to FA by mg. Tell me one thing. X ka value can exceed maximum how much? What is this maximum value here?
A by 2.
3A by 2, right?
Oh, absolutely A by 2.
So you can't, X ka value can't exceed 3A by 2, right? N can't act outside the body. So this X ka value should be always less than. So this is the toppling condition. Whenever they ask you find the maximum force or something, take it as X, solve and say X should be always less than 3A by 2 in this case. So from here you end up with F should be less than equal to 3mg by 2. This is a condition for no toppling. As long as that force is less than 3mg by 2, it won't topple. So you can get both the answers in one step here with this general thing. There's no need to solve the problem 2 times. So always assume n is acting at a distance x, find x in terms of f and all that things, and then just say x should be half of that width. Have a look at this. Anyone has a doubt on this, ask me. I'll give you one more like this, but have a look at this. If you see again, we really didn't do anything new as such. The only new thing you learned in this toppling is just make sure to put n to the side at a distance x and then just solve the problem. So here your x is the variable. Anyone, any step that you're not clear. 2 force equations, 1 torque equation. Technically speaking, we don't have anything more than that. Like those are the only things that we have techniques to solve. Okay, next one. Let's see something similar like this. Theta, it is rough mu. This is A and this is B. Mass M. Find the condition for body to slip, but no toppling. You want the body to slip, but you don't want to roll over. When I think of like this, when you're coming down the hill, you want to come down, but you don't want to roll, right? Kind of like that. You don't want the person to roll down and come down, but you want to walk down and come. You want to slip, but you don't want to roll. Find the condition. So answer will come in terms of mu, A, B, and theta. I hope the question is clear. Anyone not clear, please ask. Ali, clear the question? Yes. Switch on the lights now, Ali. It's too dark. Can't see you there. Vidyut, clear so far. Everyone should definitely do all these problems again once more. Just give it a try and get some water and come. What did we get? Mu b by 2, normal reaction. What are you talking about? N is mg cos theta.
Sorry, sir. Sorry, I mixed up two things.
X is b. What is x, Sanika? X is not asked. I didn't ask you x. I said find the condition for no toppling. Toppling but no slipping. No toppling and slipping. First thing, let's see whether you got the FBD right. Mg sin theta, mg cos theta, friction, and n will be somewhere here. I didn't ask you for x, but it is there. I didn't ask you for x though. Let's see how to use that. The first thing, you want to slip. For slipping, mg sin theta should be greater than f max. Agreed? If mg sin theta is greater than f max, you will slip. The mg sin theta should be greater than or equal to mu mg cos theta. So mu should be less than equal to tan theta. This is the condition for slipping. Actually, angle of repose, if you remember. If mu is less than tan theta, you will slip. Now, you don't want to topple. For no toppling, that means torque is 0. I will take torque about center of mass. So that will be torque due to mg, torque due to friction, torque due to n equal to 0. mg is gone. If you look at the distances here, this guy was A and this guy was B. So this will be F max. So this will be friction into B by 2 plus K cap plus N into X minus K cap equal to 0. So we get Nx is equal to Fp by 2. But remember, this is F max here. So N into X is equal to F max is again mu into N B by 2. And then cancels. We end up with X is equal to mu B by 2. But X ka value cannot exceed A by 2. Therefore, mu should be less than A by B. So find X, then say X is less than A by 2. Getting a point? X cannot exceed A by 2. So there I got the two conditions here. So for no slipping, mu less than tan theta. For no toppling, for slipping, mu less than tan theta. This is for no toppling. So which is the answer? Whichever is the smallest among them, that is the answer. So example, if I give a numericals, it will look like this. Let's say example mu is equal to, let's say theta is equal to 45, A is equal to 3, and B is equal to 1. So mu is less than equal to tan 45. The mu less than 1. This is for slipping. Mu less than A by B. This will become 3. Let me take it reverse. A is 1 and B is 3. 1 by 3. So mu less than by 3 is no toppling. So which one should I take? Whichever is the smallest, isn't it? So this is the answer. Because if mu is less than 1 by 3, both will them satisfied, right? But if mu is less than 1, this need not be satisfied. So example, if we give numericals, that will be the final answer. So among these two, whichever is the smallest is the answer. Have a look at this. Clear with the toppling part, everyone? So the main idea, right? Whenever the dimensions of a block is given, first understand it's a toppling question. Second, when you draw an FBD, just make sure to draw n to the side at a distance x. Bas itna kar liya na, then whenever they ask about toppling, find x and just say that x should be less than equal to that half of the width. That is the main idea in toppling questions. Clear with this thing, everyone? So there. So if you understood till here, you're pretty good with torque calculations. Like I said, in this entire chapter, there are three parts. Main three basic things. One is calculation of torque. Second is calculation of moment of inertia. Third is no slipping condition. If you know these three things, 70% of the chapter is in your hands. So this is the first part. Second thing, moment of inertia. So moment of inertia, the results you need to mug up. Symbol is I. So consider a body rotating with angular acceleration alpha. So on this body, if you consider a particle mi going in a circle of radius ri, the acceleration ai is equal to ri alpha. Remember circular motion? Therefore, force on this ith particle will be mass of this ith particle into acceleration of the ith particle, which is mi ri alpha. So torque on the ith particle will be ri into fi. That would be mi ri square alpha. The net torque will be summation of all these torques, which is sigma mi square mi ri square alpha. So what people observe, right? This term keeps coming everywhere, sigma mi ri square alpha. Why didn't I write alpha I? I wrote mi, I wrote ri. Why didn't I write alpha I?
Rigid body theorem.
Come again?
The angular velocity will be same for all the.
Remember, rigid body ka no matter where you stand, alpha is same for all. Yeah. So people said, yeah, since this is coming every time, let's just call this thing I. So this would be your equation, torque is equal to I alpha. So this I is given by sigma mi ri square summation. This is for particles. And I will be integral dm r square. This is for continuous bodies. So the most important thing here, what is r here? R is the perpendicular distance from the axis. It is not the position vector again. Perpendicular distance of the particle from axis. So this I, right, is actually, this is also called as rotational inertia. Inertia meaning opposition to change, rotation inertia. Physical definition of moment of inertia, that is what it is. So basically, this is a physical significance. Higher the I, more difficult to rotate the body. So same thing, higher the I, more difficult to stop the body from rotating. That is the physical meaning of it. You want definition, you say that only. The summation of the mass of the particle into perpendicular distance square. I'll just say this in more English. Sigma mi ri square. So more difficult to rotate. That's the physical significance. So basically, this is similar to mass. Higher the mass, more difficult to translate. Similar to mass in translation. You can say mass is translational inertia. Moment of inertia I is the rotational inertia. Have a look at this. Again, here also you'll start seeing integrations of different types. But it will be slightly easier than center of mass actually, because there is no x and y ka thing. There's only one integration involved. I is equal to 0 meaning there is no need to do anything to rotate. Even with zero torque, they will rotate. It's like massless bodies don't need force to move, right? Play with this page, everyone. Just a definition there. Have a look at this. Now, if you look at few properties here, moment of inertia is actually something called tensor. We don't have in the portion, we don't discuss this, but think of like this, for scalars, they just need what you call just a number to define them, a physical quantity, right? In case of vectors, you need magnitude, direction, and they should obey vector laws of addition. Tensors, right? They're a little weird. Even proper definition is not taught. It's all mathematical definitions only. But think of like this: rotations, right? Moment of inertia depends on orientation also. For example, if you take a water bottle or pen, rotating about this is more difficult than rotating about this, isn't it? You try to take a water bottle, try to catch in the center and rotate like this, or catch it vertical and rotate like this. This is more easy, isn't it? It is the same bottle, same mass, everything same, just to change the orientation. So this thing that not only depends on magnitude and stuff, it also depends on orientation. It's not direction, it is something else. So we'll not get into that. Moment of inertia, right, is a tensor. If you're in a mechanical engineering, IIT mein they'll teach you. It behaves like a scalar. So for a given axis, meaning about a same axis of rotation, if there are multiple bodies, you can just add them like scalar. It behaves like a scalar for given axis of rotation. Simply, basically, you can just add it up. Second thing, I'll give an example of this also. The second point is most important. Quite a useful one. We'll see this a lot. Moment of inertia depends on the perpendicular distance of the particles from the axis and independent of orientation of particles. Perpendicular distance of independent of orientation, meaning suppose if this was the axis, this was mass m, distance d, this is 2m, distance 2d, this is 3m, 3d, so three particles. The same thing, m, distance d, 2m, 2d, 3m, 3d. Tell me one thing, what is the moment of inertia in both the cases? So I will be m into d square, 2m into 2d whole square, 3m into 3d whole square. So did it matter like the 3m is on the right side or the left hand side? Means you could have kept this. You could have kept this m anywhere on this circle. It wouldn't have mattered, isn't it? It does not depend whether it is front, back, left, right. I don't care. As long as you keep the distance same, moment of inertia will remain same. Quite a useful logic. Meaning it looks okay, obvious kind of thing. But later on, we will solve a lot of problems just with this one statement. Saves you time. Have a look at this. As long as you keep the distance from the axis same, it doesn't matter where you keep it. You keep it up, down, left, right. It is all the same. Have a look at this. Go ahead. Let's see a question. The result is more important. We'll again see this in 3 chapters. A particle of mass m is at x comma y comma z. Find moment of inertia about xyz axis. About x-axis, about y-axis, and about z-axis. Means if you rotate this body about 3 different axes, find the moment of inertia. So this is what I said in the beginning. Remember, whenever I said find torque, what's the first question you ask? Sir, about which axis? Same thing. If I say find moment of inertia, you should ask again, sir, about which axis? So in rotational mechanics, the first important thing becomes what is your axis of rotation? If you don't define that, you can't go ahead with the problem. You never had this kind of thing in NNN. Hmm. Now listen, this is the result I want you to know. Suppose if this is x, this is y, this is z. So if you just extend this. Now, if you take some random point here, x comma, y comma, z, this is a perpendicular distance, isn't it? So what I'm suggesting, don't take this point, drop a perpendicular onto the plane. Then this point will become x comma, y comma, 0. Agreed? So from here, if you take a distance from the origin, this will be root over x square plus y square. Now you tell me, if I move this point up and down, does this distance change? You're getting at this length and this length will be always equal. That means the perpendicular distance does not depend on that z coordinate. That means whichever axis you take, ignore that coordinate. So perpendicular distance from x-axis, x coordinate won't be there. Root over y square plus z square. So be careful. Z is not the distance from the origin, it's perpendicular distance. So perpendicular distance from y-axis, ignore y coordinate, x square plus z square. Perpendicular distance from z-axis, ignore z coordinate. There, you're done. So Ix will be m into y square plus z square. Iy will be m into x square plus z square. So the meaning of this is the difficulty of rotating the body will change depending on which axis you're taking. It is not the same. M into x square plus y square. Clear? Think of it like this. Let's say you're catching a person and throwing them out. If you catch their head like this, rotating like this, or you catch them like this and rotate them like this, which one is more easy? This is difficult, right? Catching the head and rotating. It changed. The axis of rotation is different. This is more closer. Orientation, the distances matter. Have a look at this. So there, these are what is more important. The question is easy. Most people, what they do in a flow is their rate r is root over x square plus y square plus z square. So just be careful. We will again encounter this in gravitation, electrostatics, and magnetism, the perpendicular distance. Clear? Particles may, you really don't have much of moment of inertia problems. So next thing is continuous bodies. So first thing that we will encounter is rod. So I'll show you one, right? And then I'll give you more. So we have a rod here. Mass and length. So just have a look at this one derivation, and then it is the same thing there. So center is x is equal to 0, and this is x is equal to L by 2, and this is x is equal to minus L by 2. So you want to find the moment of inertia about the center. So this is the symbol for that. I show a circular arrow, means it is rotating about that. So this is how we do. Remember, what is the element for a rod? Small rods. So at a distance x, take a small piece dx. So dm will be total mass of the rod by total length of the rod into dx. What is moment of inertia ka formula? Integral dm into r square. R is the perpendicular distance. M by L into dx into x square. Limits will go from minus L by 2 to L by 2. So I will be ml square by 12. Remember the standard result, you need to mug up the results. In the end, anyway, we'll draw a table. So using this as a reference, same question, find moment of inertia about this axis. Mass m length L. Using this as a reference, what if the rod is at an angle like this? And this is actually going like this. Find moment of inertia for these two, B and C. The rod is at an angle, third one. So I showed you for the center. You do for the corner and that thing at an angle. Okay, B ml square by 3 is right. Exact same results, only the limits will change from 0 to L now. This will be x is equal to 0 and this will be x is equal to L. So dm will be m by L dx. This will be integral dm x square. Limits will go from 0 to L. Like we expected. Observed? The moment of inertia about the edge is more than the center. Means it is more difficult to catch at the corner and rotate than keeping in the center and rotating. It's actually 4 times more difficult. That is the meaning of ICA value. ml square by 3 is 4 times this thing. So it means it is 4 times more difficult to rotate about the edge than at the center. No, Aryan, that is wrong. Anusha, you're right for the third one. Adrit, you're right. See, but try. I'll give another 30, 40 seconds. Same idea here. The only difference is, now understand one thing. Whenever you take limits, whenever you take elements, the element should be always taken along the rod. Are you getting it? Don't say like this. This is x and this. You can't take element like this. X should be always along the rod, and the element should be always along the x only. So element will be still this part only, dx. So here the important thing, what is the perpendicular distance? This is your perpendicular distance. So here r will be x sine theta. Hope you're getting the difference. R is the perpendicular distance of the particle from the axis. X is not the R is not the distance from the center. So here when you take the moment of inertia, integral dm r square, the difference will be m by L dx. This would be x sine theta ka whole square. Limits will go from minus L by 2 to L by 2 because x ka value is still from the center only. So if you take this as x0, this would be x is equal to L by 2 and this is x is equal to minus L by 2. If you simplify this, you end up with ml square by 12 sine square theta. It just looks like the first one result. If you put theta 90, you should get the A part ka result. Check it out. Clear? Turn in the page. Same thing. Suppose if the rod is at an angle, now it is rotating about the corner like this. X is equal to 0, x is equal to L, lambda is equal to lambda naught x square, non-uniform rod. Rod parallel to the axis. Same idea here. Distance x, take a small dx. This will be the perpendicular distance. Only the limits will change here. And L square by 3 sine square theta. E part, let's see. Right, Ali, you got that right. Get the E part also. Arjun, you might be right. Lakshika, I think you all got the same thing. Same idea here. Distance x, take a small piece dx. This time mass will be different. That will be lambda into dx. Hope you remember what is lambda, linear density. Right, Swastika? Clear so far? Yeah. So this would be lambda naught x square into dx. So I will be integral dm x square. It will lambda naught x square dx into x square from 0 to L. That will be lambda naught L power 5 by 5. Malika, clear so far? Getting this? Clear. What about F? Zero. See, what is the distance of this point from the axis? D. What is this distance? D. What is this distance? D. All are at same distance, right? So therefore I is equal to md square. It doesn't depend on the length. Isn't that what we said? As long as you keep the distance same, I don't care, right? I can just compress the entire rod into a single particle. I can compress the entire rod to a single particle at a distance d and finish it off. Have a look at this. Clear? Any doubts on this page? Hi Vidyut, clear na? Udayan, clear with this? Swastika, Maulika, clear? Got this? Arjun, clear na? Perfect. Next thing. Suppose if you take the rod and you bent it in the center. Matlab, this becomes m by 2, L by 2, m by 2, L by 2. The rod is bent into a V shape in the center. Top view will look like this. This is the axis. Understood how the diagram is? This whole thing would rotate like this. What about this moment of inertia? You took a rod of mass m length L and you bent in the center at an angle theta, like a V shape. Clear? 7 ml square. Right, Utsa. It doesn't matter. What is the answer for this? See, suppose if you had kept the rod like this, okay, just imagine this is point A and this is point B. So what you did, you took this rod and you just bent it like this. In doing so, this point became B and this point became A. Did the perpendicular distance change? This distance is L by 2. This distance is L by 2. It is in the same plane, isn't it? So it doesn't matter. It is still ml square by 12. So when you bend the rod, you're not changing the perpendicular distance. Think of, see, it is like this thing. I keep my hand in the front. Distance is L. If I keep my hand to the left, is the distance changing from my shoulder? It is still L, right? No matter how much I rotate my hand, the distance from the shoulder is same. Getting it? So bending the rod does not change the distance from the axis. This is what I said. As long as the distance from the axis is same, you keep it however you want. Front, back, left, right. Bending of rod about center does not change the perpendicular distance. Therefore, I will be ml square by 12, the same as the first one. Check.
So, but the perpendicular distance is changing, right?
Where
From the axis of each particle.
so from A to this point is not L by 2 anymore. It is something else.
Oh, sorry. I was visualizing it differently.
It is like this, na. All will be on a circle only, right? No matter how much you bend.
Right.
Clear with this? Easy. This is easier than centromas, isn't it? उसमें x and y सब nonsense था. इसमें as long as you keep the distance same, answers will come. The next shape is arc. This is easy actually. So this is the axis. This is the arc. Theta, mass, and radius. What is the moment of inertia? Ring, mass, and radius are. Hollow cylinder, mass, and radius are. For all of them, the moment of inertia is mr square. Isn't it? Reason? The distance is same. R, doesn't matter which one you take. All points are at same distance r. Easy. So arc, ring, hollow cylinder, it is the same thing.
So this is in conformity with what you had said now, whether you place the mass on this side or that
Huh.
side.
It doesn't depend on the orientation of the particles. Next
Got
thing,
it.
disk. So if you have a disk like this, mass and radius are. Find moment of inertia. I know some of you know the result, but integrate and show me how will you do this. Because they won't ask this in the exam like this. They'll give you something else. I'll give you one weird one like this. And this is there for HSC 12th standard. Derivation is there. Moment of inertia of a disk. Try for a minute, then I'll show you. I'll help you with one. Try this thing. So this is how you choose elements for a disk. At a distance x, take a thin ring of width dx. So what you get is a like this x and dx. Take a scissor and cut it and open this. What you get will be a 2 pi x. You get a rectangle and the width will be dx. So for this strip, the area will be length into breadth. This is the area of that thin strip. So the mass dm will be total mass of the disk by total area of the disk into the area of the strip. 2mx dx by r square. So moment of inertia of the ring will be mass of the ring into radius square. Just now we calculated mr square. So 2m x cube dx by r square. That is the moment of inertia of the ring. So moment of inertia of the disk will be integral moment of inertia of the summation of the rings, isn't it? If you add all the rings ka moment of inertia, you get the moment of inertia of the disk, which is 2m by r square integral x cube dx. X ka value goes from 0 to r. That will be r power 4 by 4, that is mr square by 2. That's how we choose elements. Right, Swastika. Have a look at this, how we took the elements for this thing. Like I said, the choosing elements is the most important part. Let me give you something more weird. But got the idea? And this is there in HSA derivation. This exact thing is there. Any doubts on this? How did I choose the element? What happened? Anything that you're not clear? Great. Now you guys try this thing. You have a disk. This is theta. Sigma is the mass density, which is sigma naught r into sine square theta. Matlab, here the mass is changing with theta also, mass is also changing with distance also. You're getting it? R is the distance from center. Theta is changing also, and the radius of the disk is r. Find I about the center. So for this disk, I want you to find the moment of inertia about the center. It's a non-uniform disk. Let's see how will you choose an element. This is what I was telling you. These kind of questions, if you start doing Erido, you will start encountering these kind of questions. Meaning, still Erido is still something more easier. This is a little weird, but it's not difficult to do. Thin sectors, but within that sector also, thin sectors. Kar sakte Adrit. That's not a bad idea. I should say small rectangles actually, but yeah, it's a sector only. Try. I'll give a minute or 2 minutes. Try everyone. Main thing is choosing elements. If you figure that out, you know how to do the question. See. So main idea यहाँ पे क्या है ना, R is also changing, theta is also changing. So you should take an element such that you can't take rings here. So this is what we do. At a distance R, take a small width here. At an angle theta, take a small d theta here. So you get some piece like this. At a distance R, take a small d theta. So this distance will be dr and this width will be rd theta. So what you'll get is a small rectangle. I'm exaggerating the figure, whose width will be dr. So remember, dr should be always in the direction of r, and this will be r d theta. So we get area of this rectangle will be r dr d theta. Mass of this small piece will be sigma into dA, but sigma itself is sigma naught r sine square theta r dr d theta. Sigma naught r square dr sine square theta d theta. So I of this small piece, I of this particle is dm into distance, which is r square. R is the perpendicular distance. So sigma naught r power 4 dr sine square theta d theta. So I of this weird disk is integral double integration, because there are two parts here. Sigma naught r power 4 dr and sine square theta d theta. So since if you see r and theta are independent of each other, sigma naught integral sine square theta d theta, one integral for that, and r power 4 dr for this thing. R ka value goes from 0 to r, theta ka value goes from 0 to 2 pi. You can calculate this. That thing comes out to be half for sine square theta, and this will be r power 5 by 5. Sigma naught r power 5 by 10. Sine square theta is half. We did that integration in centromas, if you remember. Remember how to do sine square theta? 1 minus cos 2 theta by 2. So for people who are confused, integral sine square theta d theta is integral 1 minus cos 2 theta by 2 ka d theta ka integral. This comes out to be half. That you can verify on your own. Check. So this is how you choose elements. Imagine how will you take elements in for a sphere, 3-dimensional. That will be more fun. Think about it. That will be a triple integration. You will get a small cuboid. But have a look at this thing. You can get these kind of questions also. Remember, we did something like this for a rectangle plate, center of mass, sigma x y. So I can do something similar for disks also. So the double integration, the main idea is, there are two properties changing. R is also changing, theta is also changing. That should give you the idea, boss. There are two integrations involved. Have a look at this. Clear with this? Take a break. Come back with 7.5. We'll continue from here. Any doubt so far? Anything that you're not clear, didn't understand, please ask.
So can you just show the disk one again?
This one?
Yeah, okay.
In this case, why didn't I take an element like that? Because for all of them, the only R is changing, right? Only the theta is same for all. Matlab, R is, this mass is same.
Okay.
Any doubt so far? Anything? Clear? Chalo, then back by 7.5. Utsa? You're saying, na, that thing, Dada batch mein, right? Abhi tak ray optics pending hai. So that we will start there maybe after 1 or 2 weeks. So if you can match with that timings, you can attend for that one topic. And baki ka kya karenge na? It's a waste of time watching recordings also, right? Best thing would be what? I'll give you you have the notes, right?
Yes, yes.
If you don't have, ping me. Best thing would be every week, let's take off one chapter. Let's say next week you do NLM. Now, if you look at NLM, right? We did almost 51 problems. The best thing would be start going from the beginning. Wherever there's a theory, just go through the theory. And whenever there's a problem, right, just try to solve it on a rough paper. Take a rough paper, try to solve the question. So when you do this thing, right, you'll get stuck somewhere.
Yes,
So
right.
if you're able to do means you know, right? There's no point in why do you need to see it again.
Hmm.
Let's say you find something weird question. For example, in this uh, so, no, these kind of questions, little you will find some different questions. So when you get stuck, this is a question. Say, find the velocity of the point P in the middle, not the blocks. So when you find new model, you will try. Then you have a look at the solution. If you understood, great. You didn't understand, then next class we can sit and discuss. So that way, if you start doing it, let's say every week, I'm sure you can handle at least 20-25 problems. So don't try to finish off everything in one go. That will put a lot of pressure. Current topics nahi hoga. So maybe in a week or 2 weeks, let's take 2 weeks for NLM, then take 2 weeks for friction. So scan through that. If you do that thing, I'm sure like in 2 months you'll finish off everything. So whatever you're not getting after the class, we can sit and discuss. That way it will be faster. But let's say there is a particular chapter you're not clear from basics only. I don't think that is the case with you anyways. And then you can go and watch the recordings. But I don't think that's a waste of time for you. ठीक है? And ये old topics का जो भी है ना, I'll keep conducting exams on those topics also. So they will get revised on the way.
सर ये जो रे ऑप्टिक्स के लेक्चर्स होते हैं उनके डेज क्या होते हैं मतलब people?
That we have that will be in the afternoons actually.
Afternoon
Tuesday and Thursday, 3:30 to 6.
3:30 to 6. Okay, fine, sir. I'll
वो
manage.
एक ऑप्शन है, दूसरा ऑप्शन भी है, but this is better.
हाँ सर,
We'll see
Tuesday
ना, when it starts तो I'll tell you. तो then देख लेना. दूसरा बैच है Monday and Friday. That will be like evening 8 o'clock to 10:30.
अच्छा, okay.
तो देख लेना, जो भी तुझे comfortable है, you can come for any one of them.
ठीक है सर.
But then that week you have to attend both the sessions, हाँ? तो weekly 4 sessions हो जाएगा physics का.
हाँ सर,
चलो
वो तो
ठीक.
मैनेज करना ही पड़ेगा बिकॉज रे ऑप्टिक्स इज समथिंग दैट मेरे इंस्टीट्यूट में अभी तक हुआ नहीं बट यहाँ पे ओके दैट्स द ओनली
हाँ,
चैप्टर.
चलो, no problems. Yeah. अरे अनुषा,
सर वही बस जो मैंने चैट में लिखा था वही जानना था।
हाँ, देखो ना, वो मेन आइडिया क्या था ना, whenever you want to find rotation, first of all, let's say axis is this, and आपने force यहीं पे apply किया, so just assume this is like a rod R bar, right?
हम्म,
तो अभी इतना बताओ, if I apply force this way, will it go to the right or to the left? इतना तो you can figure it out. Which way will it go? Right or left?
वो मेरे राइट में जाएगा, आई मीन उसके लेफ्ट में, सो व्हाटएवर
हाँ,
यू
मतलब
कैन
screen में paper में it will go which way? So it will go this way, right?
से। या
तो मतलब rotation will be this way. What is this thing? Anti-clockwise ना?
यस,
तो
टू
right
माइनस।
hand thumb rule तो plus क्या क्या?
अच्छा हाँ,
Anti-clockwise,
प्लस
right
होता
hand
है।
thumb rule. Getting it?
गॉट इट।
Same thing if
या
the force was like this. So basically idea वही है, ये axis है. Let's say someone applied force like this. So assume there's a rod from here to here R bar and just see how will it go. Will it go right or left? It will go this way. So that means what kind of rotation is this? Clockwise rotation. तो minus क्या क्या?
क्लॉकवाइज माइनस के।
Plus,
ऑलराइट,
always assume that R bar is a rod, and when you apply force, see which way will it try to go, and that is the rotation का direction.
ओके,
Hmm? Hmm.
या थैंक यू सर।
Yeah. चलो, camp on everyone. Let's see now. Basically on this disk, na. So if you take a sector, mass m, radius r. You take a disk, mass m, radius r. You take a solid cylinder, mass m and radius r. So for all of them, moment of inertia will be mr square by 2. Again, same reason. See, if I take the disk and if I stretch it into a full disk, the sector, does the distance change? You ever seen this fan? You know, when you open the fan, it becomes a full circle. Oh, I don't know what is it called. Japanese fan, something like that's what. So the flappy thing. So the same thing, right? If I open the whole thing, I'll get a full disk. By stretching it, did the distances change? So this is the idea that I was saying. As long as you keep the distance same, you can do whatever you want. So if I open the sector and if I try to stretch it into a full disk, the distances don't change, so the moment of inertia will remain same. So the moment of inertia of a sector, solid cylinder, or a disk is same. Clear? The limits of d theta will be different. Why will you take d theta here?
So like for the sector, we integrated to find the double integrated d theta, right? To find.
And वो theta, you're saying this theta, na? That theta will cancel. यहाँ पे mass is not changing, na? It's a uniform disk, right?
Okay, हाँ ठीक है.
Uniform, na? Variable नहीं है. So this is a uniform thing. Clear, everyone? Oh, what about this one? This is a good one. This is a good result, actually. I have a right angle triangular plate rotating about this. Mass m, height is h, and the width is b. Find moment of inertia. So it is rotating about the base. Now, how will you choose an element for this? Now, someone is saying we will add one more rectangle. Now, listen carefully. Look at the problem with this. If I add one more rectangle like this about this axis, do you think this part and this part are at same distance? Do they look same? Didn't you mess up the distances? Here, the small part is very far. Here, the small part is very close. Because see, what matters is the perpendicular distance. Are you getting that? So you can't do that. So to do that, na, you have, suppose agar aisa hai na, you could have done that. If it was like this, I could have added one more like this. Because the distances don't change. So be careful with that. When you are making distances, you have to make sure the distance, mass distribution ka distance can't change. So you can't add one more triangle. It won't work. How we do this? Think for a minute. The result is pretty good one. You need to mug up the result though. mh square. Yeah, that is wrong. You can take smaller triangles. Aryan, do you know triangle का moment of inertia? You should take something which you know ना. Triangle के लिए triangle ले लिया तो क्या होगा उसमें से? We don't know triangle का. See. So at a distance x here, take a thin triangle, thin rectangle like this, whose width is dx. This is theta, and this height will be x tan theta. This full base is b. This height is h. Tan theta will be h by b. So for the thin triangle, The width is dx and the height is x tan theta. So area of this rectangle will be x dx tan theta. And remember, tan theta is constant anyway. So mass of this small strip will be total mass of the disk by area of base into height into dA. So 2m bh x dx tan theta. That is a mass. So moment of inertia of this thin rod. For a rod, what is the moment of inertia about the edge? ml square by 3. Remember, dm l square by 3. तो यहाँ पे dm is this guy 2m bh x dx tan theta. L is nothing but x tan theta only by 3. So I of the triangle will be moment of inertia of all the rods. समझ में आ रहा है क्या किया हमने? We took it as a thin rod, and for a thin rod about the edge is ml square by 3. Integrate this stuff. So this will be 2m tan cube theta by 3bh integral x cube dx. X का value goes from 0 to b. 2m 3bh and tan cube theta is nothing but h cube by b cube. This is b cube by b power 4 by 4. B gets cancelled. You end up with mh square by 6. You get a pretty good result. Independent of the base. This is not the, there's even better result than this. I'll show you in the next page. Have a look at this, how we integrated it. Like I'm saying, did you observe one thing? Integration is actually easy, right? Integration will be always easy. Simple x power n sign, itna hi aayega. Headache is getting the elements. Now you might ask like, oh, isse kya use hoga? Because exam mein they won't ask like this. You know what they'll say? They will say sigma is equal to sigma naught x. Matlab this triangle ka mass is also changing with x. Then to gone, na? Standard result won't work. Then you should know how to solve. That's the reason you should know how to choose elements, because advancement definitely you can expect questions of that sort. They won't ask you simple standard results. Mains and bits में तो चल जाता है, but advanced में they do expect this level of integration. Clear? Now a better result than this, for example, if you take a scalene triangle, if you take a scalene triangular plate, again remember this result only works about the base. And let's say this height is h. I can split this triangle into two parts. The scalene triangle can be split into two right angle triangles. Mass m1 plus mass m2. This height is h, this height is also h. So this moment of inertia will be m1 h square by 6. This moment of inertia will be m2 h square by 6. So moment of inertia of this triangular plate will be m1 plus m2 h square by 6, which is mh square by 6. So this result, even though we proved it for right angle triangle, it is valid for anything. Horizontal strips is also right. Horizontal strips may you'll take this thing, then the distance will be dm md square. ये result use करना था. F case you will use. Right, Adrit? You will use F case. I use the second case. There. So this, remember I about the base for triangular plate, not rods, will depend on the total mass and the height square by 6, independent of B. This is a better result. Have a look at this. Clear? Horizontal strips also work. So directly doing for scalene triangle is little pain. So using right angle triangle and then splitting it works better. Any doubts on this? Next one. What will you do for this guy? Rectangular plate. This is B and this is L. Now, sir. Find I for this. Rectangular plate of length L and breadth B. Moment of inertia about the center. So I about center perpendicular to the plane. It won't be ml square by 12. PB आएगा इसमें. I know you know the result, but I'm more interested in how will you choose an element and solve. Try, take a minute or two. How do you get an element? I'll give you the element, you try. So top view from the center at a distance x, at a distance y, take a small rectangle whose width is dx and whose height is dy. No, don't take rectangles. No, but you have the distance. This is the perpendicular distance, isn't it? R, which is root over x square plus y square. Now get it. You take small elements, small rectangles. So they'll become like particles. Perpendicular distance will be root over x square plus y square. Area will be dx into dy, double integration. Thin strip ले सकते हो, meaning how will you choose the thin strip? How will you choose, Anika? Horizontally or vertically?
Vertical.
ऐसा लोगे?
And then take the distance from the center as x. Like
Okay,
the
then?
width as dx.
Okay.
So m mass is for LB and then dm will
चलो
be
आ
m by
जाएगा.
LB.
चलो वो dm आ गया. Then
And then I integrated x
कहाँ पे
from
कैसे इंटीग्रेट करोगे? कैसे इंटीग्रेट करोगे? You will
0
integrate
to
what
L
term?
by 2.
नहीं, but what are you integrating? कौन सा एलिमेंट इंटीग्रेट कर रहे हो? dm l square by 12 को इंटीग्रेट कर रहे हो?
नहीं.
Just give me a minute. Huh? Yeah. बोलो. So अब इसका प्रॉब्लम क्या है ना? So I'll tell you what. If you take an element like this is B, right? So dm will be total mass by total area into B into dx. Agreed? अभी A strip का you want moment of inertia about this axis, Anika. And I don't know about that. Do you know moment of inertia about that axis? This is not this case, huh? You're getting, don't get confused between these two. It is not this case. यहाँ पे axis ऐसा है और ये rod ऐसा है. you're
Okay,
getting
sir,
this
yeah,
is come
got it.
समझ में आया axis ऐसा है
हाँ,
this thing the axis is out of the plane right axis and rod are perpendicular they're not in the same plane they're skew
yeah,
lines
sir. Okay.
so basically if you know parallax theorem right we have to use that we find about this axis ml square by 12 then we use parallax theorem plus mx square तो ऐसा होगा वो dml square by 12 dmx square parallax theorem यूज करके इसको इंटीग्रेट करना पड़ेगा but right now we don't know parallax theorem so we're not supposed to use it there is a way to do that way also but you need parallax theorem then so how to get this thing so dm will be mass by length into breadth into dx into dy so moment of inertia of this particle will be integral dm r square which is m by lb double integral dx dy x square plus y square now how do you integrate this I of the rectangle m by lb integral let's say put dy outside this will be x square plus y square into dx so the main idea here when you integrate x y is constant you integrate one at a time so x ka limits will go from minus l by 2 to x will go from l by 2 y will go from minus b by 2 to y will go to b by 2 so m by lb integral dy this will become x cube by 3 plus y square into x limits will go from minus l by 2 to l by 2 m by lb dy and that would be l cube by 12 plus y square into l minus b by 2 to b by 2 now integrate this again
फिर x square plus y square dx को आपने वहाँ पे y square constant मान के क्यों कर लिया मतलब?
because dy is outside now here see now when x is changing y is not changing
Okay, so we can.
x and y are two independent variables now so when this dy is sitting outside इसका logic क्या ना this is the meaning of this logic see at a distance x or in this case I'm taking element like this so at a distance y for all these dx's y is constant no
Right, right.
ये कैसा है ना double integration is like this computer programming में if you have written for loop for j is equal to 1 to 10 nested loop for I is equal to 1 to 10 तो if I write a I j इसका meaning क्या होगा when you keep j is equal to 1 and then you change I का value so it will be like a11 a21 a31 a41 then you put j is equal to 2 then again change x ka value isn't that what happens in a nested loop put j1 change I from 1 to 10 put j2 put I from 1 to 10 and so on so double integration is something similar it's like a nested loop in a computer programming this is m by lb and this will be l cube by 12 abhi y aayega plus y cube by 3 into l limits will go from minus b by 2 to b by 2
But
this is how you integrate
could I also do like x square plus y square dy and then फिर dx?
because both will work then you know what you're doing then you are taking an element like this so for a given x you're changing all y's
Always, okay, yeah.
so it depends you can do either way it works so m by lb this guy would be l cube by 12 into b plus b cube by 12 into l ml square by 12 plus mb square by 12 the best thing about this the reason if you see this thing it works like this since both x and y are independent of each other you can treat as if this is made of two perpendicular rods isn't it so this would be ml square by
mass वाले question के लिए क्या होगा same thing.
idea was same so you could have taken I will be ml square by 12 plus mb square by 12 because x and y are independent this works getting the idea here you could have just split it like this have a look at this now why you need to know this thing because exam mein kaisa hai na they won't ask you this question you know what they'll ask you they'll give a rectangle like this they'll ask you moment of inertia about this axis, 0, 0, and this will be L, 0, and this will be L, B. And let's say this will be 0, B. And they'll say sigma is equal to sigma naught x square y. हो गया ना? They'll ask you find moment of inertia about A. This is a variable thing. And you can try as a homework if you want. So these kind of questions, that is the reason you need to know your elements. This is easy to remember. Everyone knows the result. But once they ask a question like this, people will not understand what the hell to do. So this you could have actually split कर सकता है अभी देखो sigma naught x square y ना. You can treat this rod as lambda naught x square and this rod as lambda naught y and solve them independently and add them. It works. Have a look at this integration. Is everyone getting how to do double integration? Now then, remove your hand from your head. Sit straight. That will make you sleepy. If you give support to your head will think, let's sleep. Next one. Clear with this? The next one is even better integration. Let's see how many of you remember how to take an element. This rectangular plate, right? I can make it like this also. So rectangle, I would be ml square by 12 plus mb square by 12. If you make it a square plate, then what will happen? In a square plate, the L is equal to B. So I will be ml square by 6. You can make even something better. You can make a cube also.
Same thing.
Same thing. So I of a square and I of a cube will be same. Because you can just compress this, right? Distances don't change. So rectangle, square, cube. Clear? Now you guys try this thing. Hollow sphere. Passing through the center. Again, I know you know the result. Mass and radius are. Because exam won't ask you like this. Exam will ask you like this. Sigma naught sine theta, sine square theta, and you're gone. Cuboid will be same as rectangle. Cuboid will be same as rectangle. So this is I rectangle or cuboid. Hollow sphere and solid sphere. Let's get these two. Let's do the hollow sphere. I get the solid is a little easy only. Hollow is nice. Remember how to choose an element?
So
Guess you forgot.
width
हाँ
of
रे?
RD theta and then length of R sin theta.
याद है एलिमेंट ऐसा लेना है. In case you forgot, have a look at this picture. So it will be like a ring, right? So you have to find ring ka moment of inertia and then integrate that to get a full hollow sphere. Have a look at this thing. You can use this reference and solve. Try. I'll give you a minute. Same question. So you'll find moment of inertia of this ring and then integrate the limits.
Minus pi by 2 से pi by 2 होगा ना?
because you're going up and down. No? That's a full sphere. So at an angle theta, you take a thin strip of d theta. This is how the strip would look. This would be r cos theta, and this will be r d theta. This is r cos theta. So area will be 2 pi r cos theta into r d theta. Mass of this ring will be mass by total surface area 4 pi r square 2 pi r square cos theta d theta. So I of this ring will be dm radius square, ring ka moment of inertia. That will be m by 2 cos theta d theta, and radius will be r cos theta ka whole square. So I of the hollow sphere would be m square by 2 integral cos cube theta d theta. Limits will go from minus 90 to plus 90. How to integrate this? Cos cube theta. Now this is a little max. So you can write cos cube theta as cos square theta So there's a technique called integration by substitution. 1 minus sine square theta into cos theta d theta. Now see, if you got till here, right, you're done. Don't worry about that max part integration. It's okay if you don't get it now. Because when they actually teach you in max, this is a joke. But for now, it might look a little scary, but it's manageable. So what you do, integration substitution, put sine theta is equal to t. And if you differentiate this, you get cos theta d theta is equal to dt. When theta is 90, t ka value is -1. When theta ka value is plus 90, t ka value is +1. So your integration becomes integral 1 minus t square dt. Limits become -1 to 1. So it becomes simple integration. So this will be t minus t cube by 3. Limits will go from -1 to 1. This would be 4 by 3. So this will be mr square by 2, and this value is 4 by 3. 2 by 3 mr square. The result is important. Definitely you should mug up the result. Like, wo to import standard hai. You should know how to integrate that, because they can mess up something with the properties. They can change the density or something. Because exam, I'll tell you a simple question they'll ask you. See, they'll ask you, find moment of inertia of not full sphere, part of the sphere, which is starting at 60 degrees. Kya karenge isme? You're getting, I want only moment of inertia for this part of the sphere, not full sphere. What will change?
Theta change.
Limits will change, na? So limits will change from where to where? 60 to 90.
Pi by 3 to pi.
That's it. Pi by 3 to pi by 2. Aur kuch nahi tha. But everything else is same. But the moment people see this, they don't understand what to do. Got it? So this is a part of a sphere. So you can work that way also. Have a look at this. Got this? Now try for solid sphere. How will you do a solid hemisphere? Solid sphere. You can take discs, but अगर इसको करना है ना, this
But
would
can we
be
take hollow spheres? Radius
hollow spheres on onion का shells.
Hmm.
That would be a better idea. ये होगा cos cube theta d theta. Limits will go from pi by 3 to pi by 2. I'll leave it there. So you can try this if you want. This is a part of a shell. See, it's not really that difficult to do. Just limits change हो गया. But people who don't know integration, how to choose element, they won't understand what to handle, what to do with this. So solid sphere का, right? You can choose like onion shells. So x dx. So here the elements will be hollow shells. So dv will be 4 pi x square dx. This is the volume of the thin shell. So you took a shell of thickness dx. So dm will be mass by volume 4 by 3 pi r cube into this volume 4 pi x square dx. This will be 3m x square dx by r cube. So moment of inertia, this hollow shell, just now we derived the result, is 2 by 3 dm into radius square, isn't it? This is the result, no? Shell ka. So 2 by 3, 3m x square dx by r cube into x square. So I of the solid sphere will be add all the shells ka moment of inertia. This is the main idea. Right? You take something which you already know the result and then integrate them. 3 3 will cancel. 2m by r cube integral x power 4 dx from 0 to r. 2m r square by 5. Pretty good result. Comes a lot. Solid sphere will use this a lot. Clear? Shell or disk, हाँ, you can do with disks also, but वो complex हो जाएगा रे. Meaning you will take disk like this, and then each disk I have to add. You can do that. That will be more complex actually. Clear with this? Next one.
Sir, if you take discs, then double integration करना पड़ेगा.
नहीं ना, disk का result तो पता है तुझे already.
Oh, अरे हाँ.
This is there ना. Basically, ये जो radius will come in terms of r तो constant, only theta is variable, no?
Okay.
Do for this one. Right angle triangular plate about this axis. This is 90 degrees. This is A. This is A. Right angled isosceles plate. Don't get confused between this and this, huh? This we did already. This is easy, isn't it? ये क्या था? mh square by 6 ना? That is about the base. This is not the base. This is about the apex. Both are not the same thing. So be careful. Let's get this. Everyone should try. ma square by 4. Okay. Yeah, one answer. Anyone else got the same? Elements कैसे लिया?
Horizontal strip.
Horizontal strips. So at a distance x, I will take a strip like this of thickness dx. Remember, x should be always in the dx ka thing. And if you look at this thing, right angled isosceles, so this is 45, meaning this is x, this is also x. So area of this strip will be length, which is 2x, into width is dx. The mass of this piece will be total mass by half into base into height into 2x into dx. 4m x dx by a square. So I of this rod, this thing looks like case 6. This is the axis now. It will be dm into x square. Isn't it? Now this looks parallel, right? The rod is parallel to the axis. This is like that F case. So I of this plate will be integral I of the rod, which would be 4m x cube dx by a square integral. Now be careful, x is not 0 to a. X will be this height. How much is this? A by root 2, na? Because you're taking x from the top, be careful. That's what I'm saying. X is not the height. The limits will go from 0 to a by root 2. 4m by a square, this guy will be x power 4 by 4. Limit 0 to a by root 2. This would be ma square by 4. Yeah, ma square by 4 is the answer. Check it out. Clear with this? Now we do have some more shapes like, hollow cylinder and this thing, but those are okay. They're really not that important. Later on, I'll show you how to take elements though. In the end, we'll make a table of all the results also. So don't worry about that. You need to mug up all those. So this is one type of, using integrations, calculating everything. Now there is another way of getting this thing. We have two theorems called parallel axis theorem and perpendicular axis theorem. So let me just give the definition. Next class we'll do problems based on that. Everyone clear with the steps here? Elements, how did I choose integration? So the next theorem, right, is parallel axis theorem. I will not write the definition and all. That proof is not important. We'll just directly write the definition. So parallel axis theorem, right, what it says, if you have a body and if you have two axes parallel to each other, one is passing through center of mass. So what this says is moment of inertia about an axis A is equal to moment of inertia about an axis through center of mass plus mass of the body and square of the distance between them. Don't worry about the proof. It's not important. HSC board exam mein to hai, then we can see. So here the first thing, when to use this thing, you can use this only when the axis passing through A and center of mass should be parallel. That's why it is called parallel axis theorem. The axis passing through A and center of mass must be parallel. D is the distance between them. This gives some interesting results. Tell me one thing. Listen to the statement, okay? The height, let's say in a class, the height of the student is height of the teacher plus distance between student and the teacher. You get the statement? Height of the student is height of the teacher plus distance between student and teacher. Who is the shortest person in the class? Got my statement? Height of a student is height of the teacher plus distance between teacher and the student. Who is the shortest person in the class?
Teacher.
Teacher, na?
Not the teacher.
Teacher is the shortest person, isn't it? Because everyone's height is teacher ka height plus something, isn't it? Same way, if you observe here, moment of inertia about A is always center of mass plus something. Then who is minimum? Center of mass. So among the parallel axis, so among all the parallel axis, if you draw parallel lines, the one passing through the center of mass has least moment of inertia. Along the parallel axis, the axis through center of mass. That means it is easiest to rotate about center of mass than any other axis, any other parallel axis. The axis through center of mass has minimum moment of inertia. This is the kind of question you get in statements. Again, remember, among parallel axis, you can't take any random axis. Locus of all points with same moment of inertia is a circle. That is, if you take a body here, if this is your center of mass, so from center of mass, if you draw a circle of radius d, any point on this circle, won't it have same moment of inertia? All points on the circle have same moment of inertia because the d is same. All points at a distance d from center of mass have same moment of inertia. So the locus is a circle. This is a direct bits level question. What is the locus of all the points with same moment of inertia? Parabola, straight line, circle, ellipse, ऐसा था. Have a look at these statements. Clear? Let me take some examples. Example, let's say if I give a ring, and you have to find moment of inertia about this thing. How to choose element for this? Forget about parallax theorem, तो आ जाएगा एक step में answer. But if I want to integrate this, how will I integrate this? Think for a minute. How will you choose elements? Small arcs. Okay. I will leave it to you. Try to prove this with integration next class discuss करते हैं. But if I use parallax theorem, this is center of mass. So this we already calculated mr square. So this is point A. So IA will be I center of mass plus MD square. That would be mr square plus mr square. 2 mr square. Answer is so cool. Integration you will die. But do that. Next class, show me how will you integrate that. Think about it. Again, don't spend 1 hour, 2 hours on that. Think maybe for 6 to 7 minutes. Nahi aaya. Next day again think for 2-3 minutes. Whenever you get time, think for a minute or two. Bas. That is how you think. You don't sit with a question for 1 hour. Some of you are doing that. Someone was sent their message, every day people send daily reports. Some of you are not sending. Someone did 2 questions in 1 hour. Erido mein. Meaning, kya fayda? What are you trying to do? That is complete utter waste of time. If you're doing, let's say, Erido question, tough question. Chalo, you spend 10 to 12 minutes. Nahi aaya na, chhod de na. Next day, maybe while traveling, while going to class, or you're sitting there, maybe when you're daydreaming, think about the question. That is how I want you to solve the book. Don't give extra time to Erido and solve. That will take the fun away from it, because then it becomes then it becomes work. So what will you do when you're traveling? Let's say you're sitting in a car and coming to the house. Half an hour you're in the car. What the hell are you doing? Either sleep or solve questions. Why you want to take out your phone and play a game, or see YouTube reels or Instagram reels? Because you might think like, "Sir, kya ho jayega?" If you can solve one question every day, in an year you solve almost 300 questions. You'll complete half, almost 1/4 of Erido. And it is more fun that way. Meaning your brain will start developing a thinking ability. Try about this thing, how to get elements. If I give one more example, let's say you want about this axis. So this is the center of mass at a distance of L/4. You can integrate this, but I already know the center of mass. That's why I'm saying standard results, so you should know. ml square by 12 plus ml by 4 whole square. There. So using this theorem, you can find the answers for parallaxes. Okay. So next class when we meet here on Friday, we'll continue from here. We're going to do perpendicular axis theorem. and then we will do combinations of all these things. So we will wrap up moment of inertia on Friday, and then we'll start off with this thing, what you call no slipping condition. So this week nothing will move, but next week onwards things will start moving. Next week things will roll, jump, dance, everything we'll do. So we will see that part. But I hope everyone clear with the torque part. So we have done almost like 17, 18 questions. So make sure to go through them. Okay. So next week ka test, right? I'll get the schedule by tomorrow, but the test will be on center of mass collisions only. Okay. So we'll wrap up with this. So I'll see you again on Friday, 5:30 same time. So any doubts?